Hello and good afternoon, CTS265, Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is for the CCNP route course, and the following video tutorial is going to be on Challenge Activity 8, where we're going to be looking at implementing redistribution using route filtering. So we have the scenario down below here. It says you need to enable connectivity between two merged companies. Company A is running EIGRP, and B is using OSPF. And so this is very similar to the discovery activities that have kind of led up to this challenge activity. And we're going to make sure that we have two redistribution points. While performing two-way multi-point redistribution, you need to make sure that you redistribute into OSPF only routes from company A. Similarly, you need to redistribute into EIGRP only the routes describing the network of company B. Okay, so you also wish to take advantage of faster links when accessing network resources, so you need to make sure that R1 reaches prefixes 172.16.18 and 172.16.19 over the Ethernet links, and so that's going to be this direction here. So let's go ahead, let's get started. Let's take a look at router 3. So we'll say show IP route, and router 3 only has local information defined right now. If we were to pull the diagram up and let's take a look at router 1, and we'll say show IP route. You can see we have some local EIGRP information and a single OSPF route. Let's pull up router 4. And I'm wondering if it's going to be router 1 and 4 again here. So show IP route. And they have the internal information for OSPF and EIGRP. Router 2 has some EIGRP information, and router 5 has EIGRP only. So it looks like 4 and 1 are going to be the redistribution points. Let's take one last look here at router 6. And router 6 has some EIGRP information. Now router 3 had no information here. Let's see, show run section OSPF. So it does have an OSPF section defined, but yet no OSPF. Let's say show IP OSPF neighbors. All right, show IP OSPF interfaces. Oops, interface brief. Okay, maybe no information has gotten to router 1 yet. Let's take a look at our job aids here. And as you can see, we are definitely going to be doing our redistribution at router 1 and router 4. And again, this is very, very similar to the activity that we did earlier, where we took a look at the two-way distribution, a multi-point two-way distribution. All right, so let's jump over here onto router 1, and let's say, let's click here. So we'll say show run section OSPF, and then show run section EIGRP. All right, so we've got our 172s out of EIGRP. Let's say show IP protocols. Okay, so it's EIGRP 100 and OSPF 10. So this is very similar to the activity that we did before. All right, so the first thing that we're going to do is we'll take care of the redistribution of the OSPF information into EIGRP. So on router 1, if I were to say show IP route, it looks like the OSPF information is going to be the 10 dot information. If I go back to my job aid, it definitely is. So we've got 10.10.12.0/24 and 10.10.13.0/24. So we need a prefix list that's going to cover those two networks. So how could we attack that? So let's say IP prefix list, and we'll give it a name. We'll just say OSPF. Or I'll say PL-OSPF. All right, so that's our prefix list. We'll stick with the default sequence number of 5. Now I want to allow, and it was 10, 10, 12, and 13, and they're both showing right there above us. So we could say 10.10.0.0/16, right? And making sure that the first 16 bits matched. However, we're dealing with /24, so I'm going to say less than or equal to 24, right? So we're going to match on that. So now on router 1, I've got my prefix list for the OSPF information that matches. Now, let's go ahead and throw together our route map. So I'm going to say route map into EIGRP. Again, I'm matching the OSPF information so that I can redistribute it, specifically constrain the redistribution into EIGRP. So we'll say permit 10, match IP address. Now again, critical point here, are we using an ACL called PL-OSPF? We are not, right? Remember, this is a prefix list PL-OSPF. And what are we going to do with this? Well, actually, I'm sorry. We're just matching the IP address prefix list, so that's the name of the prefix list. Now, again, this is OSPF information going into EIGRP. So we want to set the metric, and we'll just simply go with the 10,000. We'll say 200. Oops, sorry. We'll say 200, 255, 1, 1500. All right. And then we're going to exit on out of here. So I've taken care of the prefix list to match the OSPF routing information. I've created the route map that references that prefix list. So now let's apply these to EIGRP. The EIGRP process where we're going to say redistribute OSPF 100. And do I need to put the metric here? I don't, because we set the metrics in the route map. So I'm going to say route map into EIGRP. Now, no subnets command needed here because this is not information that's going into OSPF. It's going into EIGRP. So the key here for us is to get those metrics set, which we did above in the route map. So I'm going to go ahead and hit enter. And let's do the exact same thing again. Remember, we have 2 points of redistribution, router 1 and router 4. So we'll do the same thing here on router 4. We'll say IP prefix. And in fact, what we could do, well, I won't complicate it. Well, I was going to do ACLs on this side and the prefix lists on the other side. In fact, let's do that. So I'm going to say, not knowing to leave well enough alone, I'm going to say access list 10 permit 10.10.12.0, 0.0.0.255, and then we're going to say access list 10 permit 10.10. And it's a 13? Yeah, 13.0.0.0.255. All right, so there's our access list permitting those two routes. So again, we have the implicit deny at the end. So we've got the ACL. Now let's create the route map. So we're going to say route map, and we'll call this into EIGRP. Or sorry, yeah, into EIGRP. And we're going to permit 10. But what are we going to match here? I'm going to say match IP address. Now I'm using an ACL. So I can use the ACL number. So match IP address 10. And if I do that, I'm going to set the metrics. And we'll use the same metrics of, I think it was 10,000. And then what I say, 255. And then 255, 1, 1500, I think I used. Yeah, so we'll stick with that. So we'll go ahead and set the metrics and let me make sure that's correct. I do 255 twice up here. Or actually on router 1. What did we use? 10, 200, 255, 1. So I'll rerun that statement. 10, 200, 255, 1, 1500. There we go. So let's say do show run begin route map. And there's my route map statement. Again, referencing the ACL. So we want to do the same thing here on router 4. We want to go in and apply that information. So router EIGRP 100. I'm redistributing OSPF information from OSPF process ID 10, right? That's not the route map, or not the access list number. And then I'm referencing route map into OSPF. All right. So now that we've got that sorted out, let's go ahead and do a little confirmation here. Whoops, sorry. So let me come over to router 5, I think. Yeah, we'll actually take a look at router 6, because we redistributed the OSPF information into EIGRP. So when I say show IP route, and actually let me step one step closer here on router 5. Oops, sorry. Show IP route. And we may have an issue here if there's something I missed out. Show IP route. And I am actually curious as to why I'm not seeing anything right now. So that information should be visible to me. And let's go back to router 1 here. So let's say show run section EIGRP. Do show run section EIGRP. And aha. So we've got the redistribute OSPF 100 route map into EIGRP. And that route map, do show run begin route map. That route map statement into EIGRP references the prefix list. Oh, and I put down the wrong. I put down 172's. Do show. Oh, wait a second. Did I get that wrong? I think I may have matched the wrong information. Yeah, did I actually put down 172's? And I meant to put down the 10 dots. I certainly did, didn't I? All right, well, let's go ahead and resolve this. Yeah, you'll notice, or I'm sorry, no, I was looking at the continuation here. Okay, so the prefix list is correct. So why is that not permitting those OSPF routes into EIGRP on router 1? So do show IP route. So we've got the 10.13 and the 10.12. And those routes aren't showing up over here on show IP route. Show IP route. And I'm not seeing those, and they should be redistributed in. Show IP route. Huh. All right, let's check this out here. So do show run section EIGRP. Oh, I put OSPF 100, and it's OSPF 10. So there's my typo. I put OSPF 100. It should be OSPF 10. So let's sort that out. I think I'm already here. So no redistribute OSPF 100 route map into EIGRP. And let's get the right statement here. I apologize. OSPF 10 route map into EIGRP. And we should see on router 6. There we go. Okay. So, yeah, I apologize there. I thought it was 100, and it's actually 10. So let's check router 4. Do show run section EIGRP. And I did get it correct here. All right, so router 2, show IP route. There we go. We've got our 2 externals there, and then on router 5, show IP route. We've got our 2 externals here. Okay. So we've got the external routing information correct, and we've got the redistribute statement correct as well. Let me check router 1 and router 4, route map into OSPF. And that should have been on router 4. It says redistribute into OSPF. And I called that into OSPF. It should have said into EIGRP on router 4, and I'm not sure why I put into OSPF there. So do show run and include route map. So the route map name is into OSPF when in fact the route map name should be into EIGRP. So let's clean this up here. Or actually, no, there is one there that says into EIGRP permit 10. Redistribute OSPF 10. I gave the wrong route map name here. All right. I'm a little off on this one. I apologize. So let's say no redistribute OSPF 10. So I got the process right and then put the wrong route map name. All right. So redistribute OSPF 10 route map into EIGRP. There we go. So now if I come to router 5, what I should be seeing here with the show IP route, and this is what I was looking for, I should be getting that information from 18.1, not 19.2. And when I saw that, it was coming in on the back end, right? The Ethernet 01, it should have been coming in on that Ethernet 00 interface. If we look here, where should I have been learning that information? I should be learning the information on router 5 on that interface, not on that interface. If I'm learning it here, that means it's coming this way. However, I'm redistributing right there. So it should have been picking it up here. So I apologize there. Boy, had the wrong route map name here with the right OSPF process ID and had the wrong process ID with the right route map name into EIGRP. Let's make sure this doesn't happen again as we do the OSPF component. All right. So now that redistribution has taken place, we've used a prefix list and an ACL, and everything looks good. So now what we need to do is the exact opposite, which is match the EIGRP networks and redistribute those into OSPF. And so if we were to look at the job aid real quickly, we can see we've got some 172.16s, and this makes it very simple for us. When we look at this, we see, okay, we've got 4 routes that we need to get into OSPF. What bits do they have in common? Exactly. The first 16 bits are in common. They're all /24s. So what we're going to do here is, let me get rid of that screen there. We'll come to router 1, and what we're going to say is we're going to create a prefix list, and we want to match that EIGRP information. So I'm going to say prefix list PL-EIGRP, and I want to permit 172.16.0.0/16 less than or equal to 24. Now, what this means is, again, that /16 plays a critical role. It means that these first 16 bits must be equal to the value 172.16.whatever, all the way from a /16 to a /24 inclusive. Now, my question to you is, if we had a /21, we would get that. We've only got /24, so if I only want the /24s, and I don't want anything larger, or I'm sorry, anything smaller than a /24, how would I indicate that here? Well, let's clear the screen, and we're going to use that construct. I'm going to say greater than or equal to 24, less than or equal to 24. And what that will do is it will match anything that starts with 172.16.anything.0/24, and only the /24. So there's my prefix list here for router 1. Now, let's do our route map up. So I'm going to say route map into OSPF, right? Because remember, we're matching the EIGRP prefixes so that we can redistribute them into OSPF via this route map. So again, route map into OSPF, we'll say permit 10. Match IP address. Now, I need to be careful here, right? It's a prefix list. PL-EIGRP. And that is it, right? Again, no setting of the metrics here because the information is EIGRP information going into OSPF. So I don't care about the EIGRP composite metric values, they're irrelevant. They're going to be assigned the default seed metric, which is 20 for OE2 routes that are being redistributed into OSPF. Okay, so now let's go ahead and say router OSPF 10 and redistribute. Now, what EIGRP process are we redistributing from? It's 100, and it is 100 here. We're correct. We want to get the subnets, but I want to constrain the information by saying into OSPF, and I'm referencing the route map. That's the name of my route map. So on router 1, let me come over to router 3, and again, well, let's take a look at the routing table here on router 3. Only directly connected information. On router 1, though, when I apply this route map statement here and do that redistribution, if I come back to router 3 and I say show IP route now, aha, there are all of my /24s, all 4 of them. You can see the prefix list did exactly what we wanted it to do. And the default seed metric is also displayed here. So these are administrative distance of 110, and the default seed metric is 20, right? Because we don't care about the EIGRP metrics when we're bringing EIGRP routes into OSPF. And they come in by default as OE2s. All right, so we'll clear the screen here, and the key thing, where are we learning that information? From 10.10.12.2, and we look at the diagram, that is my 10.10.12.2. If I were to do a do show IP interface brief, whoops, my 10.10.12.2 is right there, the Ethernet 00 interface, so that tells me router 3 is learning that information from router 1. If I go to router 4 and say do show IP interface brief, or sorry, do show IP route, you can see that router 4 doesn't learn those routes as OE2s. Why not? You've got it. Because router 4 has an interface in the EIGRP autonomous system. Remember, it comes like this for EIGRP. So router 4 has an interface into the AS100. Therefore, he's going to learn those routes with the lower administrative distance of 90 because they're internal to him. Router 3 does not have an interface participating over here. So router 3, when he sees those administrative distance 170 external EIGRP routes that have been redistributed in, he says, yep, I'll take them because I don't have any other information to compete with the information that's been redistributed in. Okay, let's go ahead and clear the screen here. We'll get back over to router 1. So we've taken care of router 1. We're going to do the exact same thing we just did on router 1. We're going to do it on router 4. So again, I would need a prefix list that's going to match, call it PL_EIGRP. I need to match my EIGRP routing information, and I'm going to say IP prefix list permit 172.16.0.0/16 greater than or equal to 24, less than or equal to 24. So we're only matching /24 information there. Then let's fire up a route map here. So I'm going to say route map, and we're going to call this into OSPF and permit 10. And I'm going to say match IP address prefix list PL-EIGRP. And that's it. We're not really setting anything else right now. Could I set some stuff? Sure. I could set all kinds of things, but we're not going to right now. We're going to leave it the way it is. I'm going to go into router OSPF 10. And I'm going to say redistribute from EIGRP 100, autonomous system 100. What am I redistributing? I need to get the subnets right. And we've got a route map we'd like to use that is going to constrain into OSPF is what we called our route map. Let me confirm I got that right. Yep, into OSPF. And that's it, right? I refer to my route map with my redistribution statement, and that's going to constrain everything. So now if I come back over here to router 3, what do you see? And this is, I love these Learning Lab activities. This is fantastic, right? So take a look here. We've got what? Equal cost load balancing is taking place because router 3 who's out here is learning it from router 1 as well as router 4. So all that information coming in is coming in from these two paths. The seed metric is 20, and I've got two paths over which I can send that information. I'm load balancing the information, via EIGRP. So let's test that out. If I was to try to get to, let me see, trace to 172.16. Let's do 11. I think 1 is going to be a legitimate IP. I may have to go check here. In fact, while that's thinking, let me come over to router 6. Excuse me. 11.2. All right, so that's not going to work. So I'm actually going to short circuit this right now with Control-Shift-6 and Control-C. No. All right, so I'll give it a second here. Oh, okay, it looks like it may have been valid. So as you can see, the first packet goes over, it goes 12.2, which is router 1, then 13.2, which is router 4, then 12.2, which is router 1, and then it ultimately reaches its destination. So we are load balancing, right? And there's our proof in the trace route output. So there was in the scenario, we had one thing in the scenario that was, you also wish to take advantage of the faster links. So you need to make sure that R1 reaches 172.18 and .19 conveniently right next to each other. So the 18 and the 19, that R1 goes this way to get to the 18 and the 19, and let's see where the 18 and the 19 sit. Okay, so 172.18 and 172.19 are over here, the transit links between R4 and R5 and R5 and R6. So what we're saying is we need to make sure that router 1 does not go this direction, right? Now, typically what we would do is if it was all one domain, if it was all OSPF, we could manipulate the cost, the IP OSPF cost. If it was EIGRP, we could manipulate the delay, right? And give it a terrible delay going in one direction, making the other direction look more advantageous. So since we're redistributing, we're not going to be able to do that. The redistribution is going to kind of force us, because again, remember, when we redistribute, let me explain why. When we redistribute from EIGRP into OSPF, what happens with all the EIGRP metric information? Exactly, it's gone, right? So when I do the redistribution here on router 1 and I say send all of my EIGRP information in, all of the metrics for all of this EIGRP information get wiped out, and it comes in with a default seed metric of 20. So any EIGRP routing decisions over here that are being made with the bandwidth and the delay, they're gone when I see a metric of 20 over here in the OSPF area. And vice versa. On router 4, when I send in that routing information, that's OSPF routing information, and let's say for whatever reason the metric is 10, when I redistribute it in here, do I send it in with a metric of 10? I don't. Remember, I send it in with 10,000, what do we say, 200, 255, 1, and 1,500. So that when it gets in here, it has an EIGRP compatible metric. So that's why we run into the issue here of, okay, well, now I need to tell router 1 that in order to get to these EIGRP networks, he needs to go this way, right? So how are we going to do that? Well, we can do it by manipulating the distance, right? Remember, the administrative distance can be changed. So, and is it from the, let me check something real quick here. Let's make sure that it's from router 1's perspective, but it's going to be, this is going to impact router 3. So let me double check the scenario here, make sure I'm getting this right. Okay. Make sure that router 1, okay, it is router 1, reaches the prefixes only over the Ethernet link. So it's going to be the administrative distance. So let's look on router 1 right now. And that's going to be the key here. So if I say do show IP route on router 1, how is it currently going to the 172.18 and 19? Right, because it's internal EIGRP information. So he has internal EIGRP information, which is a very trusted source. And the administrative distance is 90 for the internal EIGRP information. So he's going to take the serial link to get there. All right, this is a good one here. This is giving me some pause to think about this. So if we were to manipulate the administrative distance here, if we don't want it to go this way, right? The administrative distance is 90. What if I wanted it to go via the OSPF direction? Because again, remember, this router has an interface in the OSPF area 0 right here. So information is coming in because again, we're redistributing that information into OSPF here. So the information's coming in, but router 1 is choosing to go this way because of the routes it sees with an administrative distance of 90, which is always going to win out over a higher administrative distance. So what we want to do then is the AD for the OSPF routes is going to be 110 in this area here, in the OSPF area. So we want to make these routes look worse than the OSPF routing information that he would learn. But you'll notice it's only these two, 18 and 19. So we don't want to match 11. All right, so what we're going to do is we're going to create a, we'll keep it simple here. We'll do an access list. So I'm going to say, let me back out here. So we're going to create a standard access list. So access list, and we'll just say 5 permit 172.16.18.0 0.0.0.255. And then we'll do the same thing for the 19. Whoops. Same thing for the 19. Okay. And then we have an implicit deny at the end. So that's going to match those two EIGRP routes. And then we simply want to manipulate the distance of those routes. So let's go into router EIGRP. Whoops. So let's say router EIGRP 100. Do show run section EIGRP. All right. So we want to manipulate the distance. And what do we want to set it to? So we're going to set the distance to 130. We'll make it higher than 110. In fact, I'll set it to 200. And then the source IP address. So my source for that information is, let me pull up the actually the job aid to help me out here. So pull the job aid up, and my source is 172.16.10. So whatever router 2, because again, I'm changing the administrative distance on the routing information that I'm receiving from router 2. So let me come over to router 2 here, and I think I'm 10.2. Yeah, 172.16.10.2. Okay. So on router 1, I'm going to say I want the administrative distance to be set to 200 for all EIGRP information that I'm learning from 172.16.10.2. And it's exactly that IP address. And if I hit enter right now, that would change all the information. So let's do that. I'm going to hit enter, and I'm going to say do show IP route. And actually, we may have to give it a second here. Yeah, there we go. Wait for it to change. Now, see the problem. So for the 18 and the 19, it's working, right? So for the 18 and the 19 here, I have my OE2s, and that's what I want. However, I'm also changing this 172.16.11. We did not want to change that. We only wanted to change, and actually the job aid would come in handy here, we only wanted to change how we were reaching the 18 and the 19. I did not want to change how I reached the 11. And so that's why we've got this access list that we're now going to call into play. And this is a pretty good exercise. This is a difficult exercise here. So we're going to go ahead and call the access list into play. And I'm simply going to say I used ACL, did I say 100 or 200? Or 5. I used 5. So 5. So now I say distance 200 coming from the 172.16.10.2, and I use the wildcard mask of all zeros to match exactly that IP address. And I give it the ACL, and there we go. So we have the resync. The adjacency is back up. And when I say do show IP route, there you have it. All right, that was an excellent activity. Very, very good activity there. Okay, so, and in fact, that completes the scenario. We went ahead and we set up the mutual redistribution between OSPF and EIGRP, and we even went so far as to force and manipulate the routing information. The job aid will be a little better here for this conversation. To manipulate the routing information to say that if I had routing information, or that if I was on router 1 and I wanted to go to the 19 or the 18, that I can manipulate that to go this way by changing the administrative distance on the EIGRP information I'm learning from router 2 by setting the administrative distance to be higher than the OSPF information that I would naturally learn that had been redistributed this way, which I would have learned from 3, that never made it into my routing table because I had a better route with a lower administrative distance. As soon as we change the administrative distance on EIGRP and set it to 200, 200 is greater than, let me do this up here. 200 is greater than 110. So this new AD for EIGRP is worse than the default administrative distance for OSPF. Therefore, router 1 is going to install the OSPF learned information into his routing table. He'll no longer go that way. He's going to come this way. And then we constrained it with that distance statement where we said distance 200, and we used the 172.16.10.2 and then the wildcard mask to match exactly coming from that guy right there over that interface. And we applied our ACL, which only matched, so you can set the administrative distance for specific routes. And that is very, very cool. This is, again, another fantastic Learning Labs activity here, teaching us how to manipulate the routing information, how to redistribute, and then how to manipulate the administrative distance so that we do some layer 3 traffic engineering and force the traffic to take one path over another. Okay, well, this wraps up challenge activity number 8, and this concludes our coverage of Chapter 4 for this week. And we'll be diving into Chapter 5 tomorrow night. I'll see you guys soon.